With us now is Jeremy. He will be talking to you about passive fingerprinting with SuriCata. So, welcome. Thank you.
So like you said, I'll be covering passive fingerprinting with SuriCata. But first, a little bit about who I am. I am a security engineer at Quadrant Information Security. Quadrant is a managed security services provider. So we run a 24/7 SOC. That is the main driver behind why we started looking into this. My role there as a security engineer is to improve SOC support functions. Namely, primarily I work with the SuriCata on the back end across all of our clients, across all of our sensors. And on a personal note, I did just finish my master's in cybersecurity and information assurance. Wink, wink. Thank you. That might be important, I was told. So first off, what is fingerprinting? Fingerprinting, I'm not great at describing things, so I went ahead and Googled it and cheated. So fingerprinting is the use of information to correlate data sets in order to identify network services, operating system number and version, software application, databases, configuration, etc. So one of the reasons that we decided to use SuriCata over other programs is a couple of selfish reasons. We don't like bringing in new tools if we don't have to. And obviously other programs require other tools, other people to maintain them, other things to look after, which doesn't always work out. We don't always have control of signatures. All of these reasons for not using the other programs is they're generalized, it's not per program. And then you depend on the developer for updates. So with SuriCata, I mean, it's a system that we know, a system that we use, and the updates that we need, I mean, we just need it to do its job, and then we'll update signatures. So with that, picking SuriCata, what it does is allows us to integrate with the current tool set that we're already using and the current workflow that we have in place. It's obviously low cost, and it's customizable in the way that if we wanted to trim the load and customize the signatures that we're using per environment, whether some aren't relevant, and there's various reasons, we have full control over that. So why are we fingerprinting? Again, you know, we run a 24/7 SOC that watch multiple clients' networks. So we aren't watching our own network. We aren't always fully aware of what lies in the network that we're watching. So it's here to give our SOC a greater environmental intelligence of a network that is not ours. It helps us, or will help us once we get it fully rolled out, to improve a signal to noise ratio. You know, if over time we don't see any Linux signatures going off, or if they've completely removed the guest network from what they want us to monitor, then we can trim down the signatures, and not just the fingerprinting signatures, but the whole signature set as a whole, and that way we don't improve performance, reduce any false positives that go off, and just altogether make things more efficient. Also, with the information that we gather from the fingerprinting, it will enable the SOC analysts to do their job faster and more accurately and with greater confidence. So if they have we'll just use a random example, if an Apache struts alert goes off with SuriCata, but they know that that IP is running IIS for their server, then they can, with confidence, go ahead and call that a false positive, something that we don't have to worry about, and that might even trigger a reason to remove Apache struts from the signature rule set at that location. So for the rest of the talk, I'm going to go over the signatures. I've only started to write signatures in earnest, so I'll go over kind of what I'm focusing on now. There are many more pieces of content to write signatures about, and then I'm going to go through how we handle the data. Just fingerprinting in general, the idea is to get as much data as possible, so that's as many alerts as possible. And ideally, we're trying to get every device to set off an alert in the network so the data can be a bear to manage if we don't do it in the right way. So first off, things that I'm looking for, things that will help me fingerprint and decide what a device is. So user agents are a wealth of information. This is where I'm starting, just because it's kind of the easy win for now. I mean, this user agent example, obviously it's a Android, so a Linux subsystem. It tells us what type of phone it is down to the model. It tells us that it's running Chrome. So this one user agent is able to give us a lot of different information about that device. So not just Chrome, but what version of Chrome. So if a signature goes off, then, and it's for Chrome before version 75, then I'm not too worried on this device, for example. Ports, these are also easy wins. So web servers are obviously going to have run on port 80, 443. They're going to have the server responses that tell us what kind of web servers they are. So server responses, broadcast IPs, able to tell you what all your router's IPs are based on the fact that they're broadcasting on the broadcast IP for EIGRP or OSPF, so on. So it does just enable you to have a much greater intelligence about the target environment without having to have access to that target environment. So signature keywords, the way we organize the signatures, and later on I'll go into why these play such an important role in our system. But we locate them in the metadata. We've created 3 different keywords. So fingerprint OS. This is free form for any type of OS, Windows, Linux, Android, etc., iOS, so that when the signature is processed, we're able to grab that metadata. We know what that signature represents. Also, is it a server? Is it a client? And then the expiry of the fingerprint. Now, this is going to go directly into one of the later sections because we use this as an expiry for the Redis time frame. So how long this signature will live in Redis before it requires a refresh or before it times out. So an example is a quick example of the signatures. And just as a side note, some of these earlier talks have pointed out how my signature might not be the most efficient at the moment. I'll fix that later, I promise. So this particular signature is looking for the Samsung Galaxy S10. As you can see, the content there is looking for that model number. Samsung's gracious enough to put their model number in every user agent. And then I got highlighted here the metadata section that shows you an example of how the metadata is being used, how it's written into the signature for later use. So in addition to the signatures that we're writing in order to grab all the information that we can, SuriCata will log any DHCP information that it has. So we go ahead and ingest the DHCP logs as well. And what this does is allow us to provide the MAC address to the IP. So in the case that that IP does set off an alert later, MAC address is invaluable for the research when it comes to the incident response, tracking down the device. It also lends to the specific type of device. So if we have it, we're going to go ahead and use it, process it, record it, and keep it for later if needed. So the DHCP is moved into the same file. Instead of logging it into a separate JSON file like I normally would have, we've now moved it into the alert file that Meer will be reading. So it's in the same place that it reads any alerts that are created by the fingerprint signatures or the other alerts. It gets ingested at the same time. Meer is able to recognize the DHCP log versus an alert log, and it organizes it in the correct way. So once, I'll get into the rest a little later. It's probably just a little bit early. So for the data management, as I mentioned, this is a lot of data that we are going to be ingesting. And With that comes the need to do this in the correct way. Our first iteration was not the correct way, but our new iteration seems to work out pretty good. So we're going to go through the process flow, going to how we use Redis, and we'll move on from there. So the signatures are created, they're loaded into SuriCata. SuriCata will begin immediately to set off alerts, just because these signatures, I do put in a threshold so they only go off once an hour. I do keep it at an hour for DHCP reasons, actually. So if a DHCP lease is up, I do want to know in a relatively soon whether or not a different device now has that IP. So I allow everything to refresh once an hour, but anything more than that, it's too much. And I mean, obviously, if you guys decide to implement a system like this, the threshold is something that you guys control. So you can decide how long you would like that information to refresh. So I used JQ just to show you a little bit of what the fingerprint alerts would look like. So this particular IP set off the Linux user agent and the Android user agent, which are kind of general, and they're there for a reason, in that these signatures over time are going to begin to be out of date, right? So every Android content in the user agent does tell me what version of Android it is, but as a new version comes out, I might not be waiting for it to come out in order to write the next Android signature. So I have a general Android signature as well that would catch the next version even if I don't have a specific content ready for it. And then, there we are, it's Android 9, which is the Pi version of OS, and it is a Samsung Galaxy S9 Plus, which is also useful. So that one user agent set off those 4 signatures. Now the alerts have been created, and Meer is going to take that alert, and instead of taking the alert and putting it into the database, which is how we would handle most average alerts, we're now going to take all the fingerprint data and store it in Redis. And it's going to be stored there as you see it here, with the keys of fingerprint. It is a fingerprint event. This is the IP, and this is the SID. As you see here, this is the SID that it pertains to, so the SID of the fingerprint rule that went off. And it's stored there for later until it's needed. This is an idea of what the keys look like when you pull the individual keys. So it's pretty straightforward. Just like the way SuriCata will just insert the string into Redis, so does Meer, and it stores the information there. So once the alert happens, this is the part where we start to bring all this information together. So now we're storing this fingerprint information in Redis for a lot of devices across the target network. And it's not necessarily going to be useful for the SOC analyst to know this information until an alert that involves that IP that's been fingerprinted actually goes off. Once an alert, a true alert, goes off with that IP that has been fingerprinted, then it's going to be important for us to grab the information out of Redis and get it to the SOC analyst at the same time as the true alert. So the process from here is that the actual alert is generated from SuriCata. Meer will then check Redis for any relevant data to that IP, whether it be the source IP or the destination IP. It does check for both. Any relevant data in the Redis database for those IPs will then be sent to our backend, to our SQL database, along with the alert that was generated, so that when the SOC console displays the information, it doesn't just display the alert that has gone off, but it displays all the fingerprint information that we have to go with it as well. That way, in one nice, easy screen, the SOC analyst is able to go through the data. It limits the amount of research that they have to do. And it does increase the SOC intelligence and the amount of time. It also adds, so the customer if we mark a rule of false positive or not applicable to that situation, generally the customers are asking why, and this enables us to go through and give a much more clear and defined reason as to why we decided that that didn't apply in this case. So why Redis? When we first implemented this, we stuck with our normal processes, and every alert was then put into SQL until we realized that my initial just 25 signatures that we were using just to kind of test the system created tens of thousands of lines in SQL, and it was like 12 hours. So I immediately decided that that was not going to be scalable, especially since it wasn't even in a live environment. So we scrapped the first idea, and it wasn't my brainchild, but I'll happily take credit for Quadrant as a whole. But we began using the Redis database instead, and it allows the data handling there is more dynamic. The data is there and readily available. It expires out based on the expiry time that you set in the rule. All of my rules just at the beginning, they're all set to expire within the day. So over the day, if a similar Redis entry happens, that's fine. Kind of overwrites itself. But if that IP disappears within the day, then we're no longer storing that information that we don't need. So the rule keywords, again, just to iterate, with this fingerprint OS, the fingerprint type, and the fingerprint expiry, and this is when the expiry begins to be important. And this is completely configurable on your end. If you'd prefer to hold keys for less time, then you can. If you prefer to hold keys for longer time, then you can. Whatever is appropriate for your network. And then we did create a new class type, and we called it fingerprint, as is appropriate. This is so we don't treat it as at the same level of priority. This is simply, as the better system might call it, research. Appreciate the better system, by the way, wherever you are. So long-term storage, obviously Redis is not there for long-term storage, but it would be useful to solve that issue as well. So when Meer is busy doing its job, it also outputs an EVE.json file with all the relevant information that you're going to need, so including the fingerprint alerts and DHCP lines, and those can be then ingested into Elasticsearch. So for the example of DHCP again, where that device the IP that belonged to the device may no longer belong to that device, then you're able to go and do an historical search through Elasticsearch, find out in the time frame that you're worried about what device had that IP. Hopefully there's a MAC address in there. Again, it's not our network. You might be able to find MAC address in a different area that might be more efficient, but we're going to record it just in case. This is the best way. So everyone likes to do their historical research, and everyone likes to ingest their logs into Elasticsearch, so we've provided that for you. So a little bit of what this looks like in the end. This is all dev, so the detailed eyes out there may find some inconsistencies. I'm just going to tell you they're there. Dev issues. This is not a live environment, but so as you can see, this is the fingerprinting, all the fingerprinting information that exists in the Redis database at that time, and sorted out by IPs, how many fingerprints exist for that IP, what in general the OS types are for that, for those signatures, and how many of them specify that as a client or a server. And then if available, the MAC address will be presented as well. So if you do want to know what your environment looks like at that moment, what the Redis database holds at that moment, you don't want to wait for Elasticsearch, or you don't need to go that far into the past. then the data is right here for you in the console, or however you guys would use your consoles. This is obviously ours. Now, once you click on the View Fingerprints, then you're going to see the different fingerprints that have been set off in order. So obviously here we have the general Internet Explorer user agent, and then through my test data, it also set off the Internet Explorer 7 and 9. It's obviously Windows. It communicates with a SMB server, and it was running Jabber 12 for Windows. So, just at the moment, I've only got about 300 signatures. About half of them are for cell phones. So as time goes by, there will be thousands of signatures, and the information that you get from this screen is going to be much more detailed about each endpoint that you guys have. And then in the SOC, if you dig into each line, then you're going to get why we decided that it was Internet Explorer 7. And so that includes the payload and then a reference to the MAC if it's there. And this is what you will provide to your customers or to yourself if you wanted to question whether or not that signature was accurate or why it went off in that way. This is the payload that encouraged us to say that this is running Internet Explorer 7. So this provides the proof behind the signature. Now in the SOC, you would see something similar to this. This is SSH brute force login attempt went off. Okay, not a big deal on its own. What do we know about the computer? It obviously is a dual boot. It runs Mac and Windows. But you'd see the fingerprint information right here in the alert itself, and then they'd be able to go in and access the previous panels that I just showed you if they needed to provide that proof to the customer or prove it to themselves, as any analyst should. But it's all there at their fingertips when, in the past, a SOC analyst, if they needed to research into whether or not an alert was valid for that endpoint, they might go look at user agents, but that requires them to go through the metadata and do that research manually, and it takes time. And if it's something that's critical, you don't always want to have to take that time. So this puts the information right in front of them. They may still have to go in there, but they're going to be looking for the more important data and not just deciding what device is this. So in general, that is the system in a nutshell. It is going to expand from here now that the basic process and the nuts and bolts work. And as we go, there are going to be more fingerprint rules. We've made them available through GitHub, and if anybody just loves writing rules and feels a want and a need to help, then please feel free, or I will be writing these thousands of rules on my own. And then if you are interested in Meer, you're going to hear a lot more about it later. I believe Champ has a lightning talk, but that is also open source and easily available through GitHub. Again, Meer is the way we handle our data, and it makes it effective. Any questions? Awesome. I did an excellent job explaining. Thank you.